Okay, so I'm going to show two problems here. So there's this one, and then there's this one. So first we'll start with this one. So first, a good first place to start is just try saying limit as h goes to zero. So just try plugging in zero. But if you do, you can see it's not going to work. You're going to get 9 squared minus 81 over 0, which is 81 minus 0 over 0. That's an unclear formula. Whenever we get 0 over 0, it's unclear. So we have to try something else. So what are we going to do? Well, let's try just multiplying out 9 plus h times 9 plus h minus 81. Make that a little nicer. All over the h. And we'll put the limit back in front. Limit as h goes to 0. So 9 plus h squared, I just wrote two of them. And then let's just FOIL it out. So this 9 goes to both. Be 81 plus 9h. And then this h goes to both. Plus 9h plus h squared. Then we still have the minus 81 at the back, all over h. Okay, so what does that do? Well, 81 minus 81 cancels. 9h and 9h is 18h plus h squared over h, like that. Oh, and I forgot the limit's still in the front, huh? You can't lose that limit. I tend to lose the limit. Limit's still in the front. Okay. Now, you might think, okay, do it again. So plug in 0 in the top bottom. Well, you're still going to get 0 over 0, right? Still unclear. It's still not going to work. 0 over 0 does not mean 0. It does not mean infinity. It's unclear. So we have to do something else. Now, you might say, yeah, we'll just cancel these h's. Boom. And then you can plug in the 0. The 0 is just there, and then the answer is just 18. Well, and that's the answer they got. So it's right. Well, you got lucky. That's not good math logic, and that won't always work. Instead, even though, yes, it does get to the right answer, you cannot cancel those H's. You cannot cancel things that are added and subtracted. Let me write that note. Really important in calculus that you get that clear. You cannot cancel added, subtracted items. Why not? Well, just think about it. How about 2 plus 4 over 2? That's really 6 over 2, we know, which is 3, right? Sorry, that 3 is a little janky. There we go. Right? But if you cancel the 2's, all of a sudden it's 4. See how that's just not right? It's just not true, right? That proves it's illegal. It's wrong. It's just not true to cancel added items. You can only cancel multiplied items. Okay, well, then what do we do? Well, we change the top to be multiplied. You factor out the 18 like that. And then we can cancel those H's. Now it's okay because now those are multiplied. That's H times. So a multiplied items are okay. You just cannot cancel added, subtracted items. And now you can plug in the 0. And indeed, the answer is 18, which we did get by the cheaty way. And trust me, it won't. You might say, well, whatever works, but no, the other way won't always work. It'll give you the wrong answer sometimes. So that's how we do it. Let's try this one. How about this one? Well, same kind of thing. If you plug, it says limit x goes to 1. So if you plug in 1 there, see we're going to get 0 on the bottom. And that means infinity. So then this would be infinity minus infinity. You might think, well, infinity minus infinity is 0. Well, it depends on the level of infinity. That's just unclear. It's an unclear. We don't know what if the first infinity is of what we call faster infinity, higher level of infinity. Then anyway, it's a long story. It's just not clear. You can't say it's 0. We don't know what it is. We got to do some kind of simplification. What can we do? Common denominator. Well, we should begin by factoring actually. So let's do this. Bring this on down here. This is going to be 4 over x minus 1. This guy I'm going to factor. That's x plus 1, x minus 1. That's going to come up a lot in this course. You want to get familiar with that. Do you see that? See, I'll check it and prove it. If I was to multiply that out, boom, boom, that'd be x squared minus 1x, and boom, boom, plus 1x minus 1. See how these would cancel in the middle and just go back to x squared minus 1. It's right. So this denominator is x plus 1, x minus 1, right there. Okay, so what? Well, now we can get a common denominator. If we multiply top and bottom of this one by x plus 1, now this denominator will match that denominator. So then what do we get? Distribute this on the top. We get 4x plus 4 over x plus 1, x minus 1, minus 8 over x plus 1, x minus 1. That good? Now we can combine them into one fraction because now they have common denominators, right? These are common. You've got, in order to add or subtract fractions, you have to make the denominators the same. So we made the denominator same. Now we've got 4x plus 4 minus 8. And then you just have the one common denominator. Okay. And now that leaves us to 4x minus 4, right? 4 minus 8 is minus 4. In fact, let's just, well, okay, I'll keep going. I was going to skip a step. That's right. X plus 1, x minus 1. So I'm running out of room and I'm getting scribbly there. All right. So now what? Oh, by the way, I think I long ago forgot the limit in the front. I do that. What was the limit? It was x goes to 1, wasn't it? I'm going to get scribbly here. Problems are going long. Yeah, limit x goes to 1. Okay. Of 4. Now, what am I going to do with this right here? You might say, well, plug in the 1 again. If you plug in the 1, you're going to get 0. This part will be 0. It's not going to work. So we have to now, we're almost there. I know it seems like forever here. Factor that top. You see that? So that 4, boom, boom, before x minus 4. Now, boom, boom. That's going to take care of the problem because that was what was making the 0 over 0. So if you plug in 1 there, that's 0, that's 0. That was what was causing the problem. Now we have limit as x goes to 1 of just 4 over x plus 1. Now you can plug in the 1 and it won't cause a problem. 4 over 2, the answer is 2. So that was a lot of steps there. What do we have to do there? Going back to it. We saw this and we had to factor the denominator, x plus 1, x minus 1. And then we said, all right, to subtract two fractions, you got to get a common denominator. So you got to make the two denominators the same. So we multiplied top and bottom. Whenever you mess with a fraction, you got to do the same thing top and bottom so you don't change the value of the fraction. Multiply top and bottom by x plus 1. Make the two denominators the same. Distributed that out and combined them into one fraction because they have the same denominator. And then we factored the top, canceled, and then finally we could plug in the 1 and get our answer. We wouldn't get any weird, unclear forms. So there we go. And this one up here, we had to just multiply it out on the top. And then in the end, we had to factor the top as well and cancel because you can only cancel multiplied items, not added, subtracted items. Make sure you know that going forward. All right. And there we go.